Hello everyone and welcome to yet another recreation programming session with Mr. Zozen. So today I want to just try for the second time to implement a custom build system for our programming language. Not really our programming language, I keep calling it our programming language when in reality it's a Ken Thompson programming language, but we're implementing a compiler for it, right? So, and I think it's quite important to have a custom build system because whatever we're doing with makefiles is just doesn't cut it, right? Doesn't cut it at all. And we need something more powerful, right? So, and I think this time I've come up with pretty good idea on what exactly I want to have in there. Build system. Did I say build system? I wanted to say test system, right? So yeah, so we're going to be making a test system today. It's not really build. Well, we can build with it, by the way. We could build with it, right? So, but so far, I plan to just only test with it. Rorinka, thank you so much for the sub. Thank you. Right. So I'm gonna start over. Right. So whatever I was experimenting in the previous session didn't really work out. So let's create something like, I don't know. I still don't know how to call it. Let's call it something like a beat test. It's like best. That's. No, it's kind of difficult to actually see instantly that it's related to testing. So I think I'm going to call it, btest. Because when you look at the word best in a list of files, it doesn't immediately occur to you that this is a build system, right? So when you see something like btest, and it actually kind of stands out, showing you that, yeah, it's something related to testing, right? So I think it's better to call it btest. Even though best is kind of a cool name, I'll give you that. Actually. So let's actually create a usual Crust template. So this is the usual Crust template, right? So the signature here is a little bit long, but who fucking cares? If Java developers do not fucking care, why should we care about, long signatures and stuff like that? Neighbors are doing something sus outside, I think. Hello btest, right, so I'm going to put something like that, and on top of that we have to include, by the way, pub mod. I just realized recently that mod operator or statement in Rust is basically include, but for the module system of Rust. It never occurred to me, right? So, and it's just like each individual module in Rust is not a translation unit. Translation unit is a crate, and in a crate you have a root module that mods other modules, which mod more modules, and so on and so forth. And in that regard, mod acts like include in C and C++. It never really occurred to me, and of course documentation of Rust doesn't really make it super obvious. You kind of only notice the parallel after you worked with this system long enough, but that's what it is. Mod is basically like include, even though you may think that use is the include, but use is include for specifically for the interface. It doesn't really link with this outside. Well, it does kind of link. It's kind of difficult to say. Use is not really include. It's more like using in C++. Yeah, Kotkat, you're right. I was about to say that. It's more like using from C++. The actual include is actually mod. Right, but mod includes code that will be linked into your translation unit, aka crate. So there's some parallels, but they're not, perfect. They're not really perfect parallels. It's kind of interesting, actually. So anyway, Crust, and as far as I know, we also want to maybe export some macros, macro use. Yeah, and use, as you can see, it's using. Macro use. So if I don't use macros, does that mean I have to use all of them like this? I don't even remember what kind of macros do I even have in here. Oh, I have C. Okay, so does that mean I have to do something like that too? Actually, I'm kind of curious. I don't remember how the name spacing for macros work, but we'll see. Anyway, let's try to build this motherflipper. Let's fucking go. So btest, right, so it's going to include all of these things. Can you see Scheisse? Yeah, you can see Scheisse in dismissed, and this is btest. So maybe it would make sense to have some sort of a phony target in here, which basically depends on btest, and instantaneously run it right away. So that way we can do btest. So what does it say? You can't do shit like that. Could not find C in Crust. Yeah, so and in Crust, did I? Yeah, I exported it, so I have to use macro use, and only then I will be able to, yeah, I keep forgetting how all of that shit works. Still doesn't really work, but this is because we never really included or used core FFI star, right? So because cchar is available in there. Woohoo! I get you catch a stream on my birthday, Simantra. Thank you so much for the sub and happy birthday, my friend. So, oh, happy birthday to you, happy birthday to you. Anyways, so we have some. Oh, okay, so as you can see, it worked. It complains about some stuff, right? So it complains about some unused variables and stuff like that. But this is because it's Rust. Even though we castrated, no, crustify it. So actually, C Rust stands for castrated. That's what it stands for. I just realized that that's what it stands for. Anyway, so it's we crustify this this Rust. It still complains. It still fucking complains, right? So I don't really know. But I mean, so unused variables is not that big of a complaint, right? So it's not that big of a complaint. Worse Rust. Yeah, it's kind of a worse Rust. I'm not sure about better C. Well, it's definitely a better C. It is definitely better C because it has lambdas, by the way. It actually has lambdas. Right, it doesn't really have captchas, if I understand correctly, but it does have in fact lambdas. So we can do some stuff like this. So we can do foo, and here I can accept a function which maybe accepts some sort of a, I don't fucking know, number, which is going to be i32 and returns the number. And what essentially we're doing in here, so this is i32, we're going to return f 69, right? So we're going to return f69. And in here, what I can do is just print something like this, foo, and then I can say, okay, x, and then just like a double x, right? And that will work. So if I try to build the whole thing, it does in fact work. It didn't rebuild anything. No, it didn't fucking work. What the fuck? Yeah, so now it works, right? So this is basically twice of 69. But here's the interesting thing. As far as I can tell, it won't capture anything from its surroundings, so it doesn't have closures, right? So if I try to do something like this, it obviously won't work, but that's already better. That's already better than C, because C doesn't even have non-capturing lambdas, right? So closures, yeah, so because if you try to do something like this, a fn is effectively a function pointers, and the function pointers cannot capture its surrounding, right? So to capture, to be a closure, you need to be an object. So the question is like, you have to use things like fn, right? So as far as I know, fn captures, and also there's fn mute and fn once. There's quite a few of these kind of things. And are they all available in core? That's the real question that I have in here. Are they all available in core? They might not be available in core actually. So if it's fn, so there's ops. Okay, so if I have core, ops, oops, fn. So is it available anywhere? Yeah, so they are in fact available in core. Look at that. Look at that. Look at that. But I'm not sure how Crust they are. So, oh, they recently, not recently, but they also have fn. There's so many fns. Anyway, so in my opinion, in practice, you don't really need that much. Right, so function pointers is more than enough. If you want to capture something, well, you can always do some shit like arg, and you can accept that arg in here. And in fact, you have generics. You might as well do shit like this or whatever, right? So it's just like, if you want to put like a pass arbitrary value in there, you can, right? Who said you can't do that? You should be able to do that. So here is your y, and I pass y in here, and if I try to rebuild this entire thing, so is it going to work? No, it doesn't really work, because I'm supposed to put this thing in here, and it works, right? So closure is about that. Closures is about attaching additional data to a function pointer. That's what it's all about, right? So if you want additional data with the function pointer, you can pass it along with it, and that demystifies the whole offense mutes and stuff like that. That's probably what they're doing under the hood anyway, right? So, and it's just like it's a more open system, right? So I don't know. I kind of like in that regard where C3 is going, actually, and also Jai. I think Jai is also doing the same thing. It's just like they have lambdas, they have function pointers, but they don't have closures. Right. So because if you need a closure, well, you can just attach additional information. There you go. You got the closure, right? Just do it yourself. It's not that big of a deal. It's not that big of a deal, and the whole system is less magical than if you were trying to capture things, right? So just like it's a little bit of more complexity to the compiler and stuff like that. You know what I'm saying? I kind of like this approach, and maybe in Crust, we could mandate it as a rule, right? So if you're going to be using function pointers, right, lambdas and stuff like that, only use function pointers like this, right? So we'll see how it goes. Anyway, whatever. Okay. So if you define function inside of other function in GCC combined with block expression, you can have closures, but GCC just uses executable stack. Imagine executable stack in Rust. I wonder, does Rust use executable stack anywhere? I don't think so, actually. It's a little bit too unsafe. Anyways, so let me just look at the list of files. Let me take a look at the list of files. So, what are we going to have in here? So here is the list. And so I'm going to just grab all of these things in here, and here are our tests, right? So we're going to be iterating through all of them. So it's going to be tests. I actually want to have them as test names. Query replace B, and this is just the test names. So const cchar, and I'm going to just put the stuff in here. Can I put a comma at the end of all of these things? I should be able to do that, right? So that seems to be all right. So, and the idea here is that what I want to do is I want to have a matrix, right, where I test a particular test on a particular target or on a particular platform, right? So we need to generate some sort of a matrix. Right, and what I'm thinking, the way I plan to do that, right, so maybe we're going to introduce some sort of a structure, right, so some sort of structure which is going to be a report, right, so this is going to be a report. And for this structure, we're going to have the name, right, so this is basically the name of the test, right, and this is the name. And then we're going to have an array of statuses, right? So let's actually go to maybe statuses, right? So, and it's going to be, I don't really know. So we can make it a dynamic array for now, right? So it's going to be struct status, and the status could be OK, or maybe something like a build fail, right? So that means the test failed to build. It failed to build, or maybe we could also have run fail. I plan to add more, maybe like an output fail when you like compare the output and it's not something expected. So we're gonna have like a several phases of failure, right? So maybe the entire thing builds, but when you run it, it fails with a runtime error. At the same time, maybe failing with a runtime error is an expected behavior. And maybe build failure is also an expected behavior when you test in, you know, incorrect syntax or something like that. It's kind of difficult to tell, but for now, I'm going to just keep it like that, right? So because negative testing is also testing, isn't it, right? So why test only positive things, right? But I mean, changing that, it's not that difficult in the future, I think. It's not that difficult in the future. Right, so, and this is going to be an array. This is going to be an array where each element corresponds to a target. Right, so essentially you have a particular name, right, so, and basically on different targets, so on the first target is going to be OK, it passed, on another one is going to be OK, and then on another one it failed to build, right, and then OK, and we're going to have as many elements in here as we have targets, right, so, and as far as I know, It's relatively easy to get the list of targets in here, because here it is. So here is the list of targets that we need in here. So, and each element by the index corresponds to this element in here, right? So that's basically what we have in here. Right, something like that. And we are going to have a bunch of these things. We're going to have a bunch of these reports, right? So it's going to be an array of reports. Report, and it's going to be 0 yet. 0 yet. So that means we're going to have something like that. And this is basically a matrix, right? This is basically a matrix. And what I want to do, I want to just like iterate this matrix, right? So the one axis is the current test, another axis is the target, and just like test each individual thing, collecting all of the statistics, and then generating some sort of report. Right, so the report is going to be right now in the terminal, right? So then we can generate maybe some HTML, static HTML, so it looks pretty, right? So imagine if this would like be HTML table, right? So we're not going to be using HTML tables, but you know what I mean, right? So it's just like a table, which is really easy to look through and see what kind of tests are failing and stuff like that. HTML plus CSS, yes, exactly. Maybe a little bit of a JavaScript, but don't count on that. So, and then we could automatically deploy that HTML report to GitHub pages on every CI build or something like that. So like at any point, anybody would be able to just go to that web page and see on which targets, which tests are failing and stuff like that. That's my wet dream of how the test system will work. And it's obviously kind of difficult to implement this kind of stuff purely in Makefiles, because this is basically the current state of the tests with Makefiles. It's pretty sad, all right, because we don't have a powerful language in here that we could, you know, use. B-standards test suite. That sounds like a cool idea, actually. Just have some test suites. I don't think like there's any test suite that exists, but we could create one. So right now, the way we add tests is actually kind of stupid. It's just like we add whatever. So somebody just works on a particular feature, and they just add in a bunch of bullshit, right, just to test that specific feature, and then they already have a bunch of bullshit that kind of tests that specific feature. Why don't add it to the test suite? So it's not really rigorous, where we went through the entire spec and based on the spec created some tests and stuff like that. It's just like, it's like whatever. Whoever was working on that, like, edit some stuff and we just, you know, run it from time to time. Is plan B to support equals plus to later, or just plus equals? I plan to add this kind of thing much later, because like it's relatively easy to add, because it's just a change in Alexa, right? So somewhere here in Alexa, if you take a look at that, so we just have a table of all of these things. This is not the table, this is the table. Right, so look at that. It just maps these sequences of characters to a specific token, and the parser operates on these values, on these tokens. It doesn't know anything about specific combination of characters. We can just have a separate map to different thing in here. Right, so, and maybe we can have like a compatibility flag. Right, so you enable this flag and it uses traditional operators, traditional tokens, and we could use that to compile a historical B code, right? So find some code in the wild that was literally written by Ken Thompson, just enable this flag, try to compile it, see if it works or not. But for actual recreation programming, obviously this kind of tokenization sucks, right? So you want something better, right? So you disable this flag and it just supports both. We could support both, right? So, and we can make these tables sort of swappable. We could make this swappable. So anyway, okay, so let's freaking go. Let's freaking go, my friend, freaking go. Historical B, exactly. Historical B. So here is the stuff. And so this is the statuses, build fail, run fail, and so on and so forth. Okay, so what we want to do, maybe we want to have some sort of a function in here. So run test. So here we're going to accept the test name. So this is the test name, and we're going to accept the target. The target, so this is just the target, and I suppose it's going to just return a status, right? So on top of that, yeah, so it will fail at different stages, right? And depending on which stage it failed, it will just return different things in here. So for now, it's unimplemented, something like that. It is in fact unimplemented. And so now I want to basically iterate through all of these test names, right? So we're going to be iterating through all of these test names. 0 test name length, then we're going to have test name, test names I. There we go. So let's do something like test as test name. Let's fucking go. So I'm gonna do make b test. All right, I'm in the wrong folder as usual. All right, so where does it fail? It fails because this is supposed to be enumeration. That's understandable. What else do we have in here? Array. It doesn't have array. I don't remember where do we define arrays. So struct array. So it's somewhere in a knob. So let's do mod knob. Maybe also use macros, and I'm gonna use everything from knob. So what else do we have in here? So let's go to the build and rebuild. Okay, so target is not available. That is understandable. It is available in the targets, and let me import everything from the targets like so. From the targets, zero-yed. Okay, zero-yed means that we have to import from memory. So this is the zero-yed. So here are all the tests. That's pretty cool. So now I want to iterate for like each individual target in here. So I think it was target name. It's kind of interesting, iterating test names and target names, right? So in a Cartesian product fashion, if you know what I mean, right? So you guys know what is a Cartesian product? You guys know what is a Cartesian product? When you have an array and another array, you put them as axes and you generate a matrix out of them with pairs. That's what Cartesian product is called. Cartesian product, right? I already talked about it. It's a notion from discrete math, actually. A Cartesian product, yeah, so this is precisely what I said. So you have one array, another array, you put them on axis and you generate pairs with a nested loop and stuff like that. This kind of operation is called Cartesian product, if anyone wanted to know. So this is basically what they taught us in university. That's the only useful knowledge, semi-useful knowledge that I got from university. So I'm pretty sure if I didn't go to university, I wouldn't know that and I wouldn't even give a fuck, right? So it doesn't change anything. Descartes product. Well, I mean, it depends, right? So in Russian we call it Descartes product. In English, I heard people call it Cartesian. So like, what's the difference between like Descartes and Cartesian, right? So is that the same dude, right? So just like his name is pronounced differently. Right, so I don't really know. But anyways, so let's iterate the target names. The same, yes, okay. Cool, nice to know. So here's the target names, and as far as I know, the target names is like it's a structure. Okay, so target name, and what we have in here, we have a name and we have a target simultaneously, which is kind of convenient. So we don't really care about the name, but we do care about the target. So Ready Player Parker, thank you so much for the sub with the message. This has been one of my favorite stream series, 10 out of 10. I'm really glad to hear that. I'm really glad to hear that people are enjoying this kind of series. Right. So there's something interesting. So there is this YouTuber, like art YouTuber. I think her name is, yeah, so her name is Picard. And she's doing like YouTube videos on how to do art and maybe run an art channel and stuff like that. She recently made a video about like marketing your work on social media, and a lot of things she says is actually applicable to programming as well. What I noticed is that one of your observations about art content that I feel like I missed when I was doing programming is that some communities are smaller, but they're more focused, right? So my main problem is that, like, to grow my channel, right? So I have to appeal to the masses, right? So I have to appeal to the masses by doing slop and stuff like that. But sometimes I don't want to do that. Sometimes I want to do these kind of like nerdy topics, like a weird old language compiler and stuff like that. And obviously it gets less appeal from the masses, but it gets a lot of appeal from the nerdy part of the community. But that nerdy part of the community is actually, even though it's smaller, it's more focused precisely on this very thing, right? There's more focus, and because of that, they're kind of like engaging more, and they bring in more energy than these amorphic masses that are only interested in slopes. It's just like 1 million slope enjoyers is actually not equal to 10 hyperactive nerds who will submit you high quality PRs to your projects. It's actually not the same. And this is something, for some reason, I wasn't really appreciating until I watched her videos. So yeah, it's kind of interesting. It's only started to occur to me recently. So maybe I should change my content strategy based on that. The chair is back. Yeah, so the chair is visible or not visible depending on the angle, right? It's not like I'm moving the chair around, I'm moving the camera around actually. So nerds are more likely to support you too monetarily. That's a good point actually, because nerds probably have a high paying job, right? So given the current, you know, state of tech and stuff like that. So yeah. So let's freaking continue. Let me see. So here is, yeah, so essentially now we have a little bit of a Cartesian product in here, as you can see. And on top of that, I might as well just like also specify the target. It's not really clear, right, what we're doing in here. So though I don't have a name, so I need to have like a target name in here. So here's the target name, right? So here's the target name, and yeah, as you can see, here is basically pairs, right? So even though that's a really weird, so I would expect it to alternate, and this is because I was using a wrong iterator. Yeah, so now we have the thing. Now we actually have the thing, and this is actually kind of cool. So yeah, let's go ahead and maybe run the test. Let's run the test. So this is a run, a name, and the target. Right, name is not really needed in here, right? So, but we got the status, and this is exactly what I want to do in here, right? So I just want to append this to the current status. So maybe it makes sense to create some sort of a report in here, the current report, which is going to be 0 yed, like this report. And so as we not necessarily 0 yed, but we can say this is going to be the name, and the name is the current, you know, test name, like this. And statuses is going to be 0 yet because it's dynamic array, right? So I want to have an empty dynamic array. And as I go through all of these statuses in here, I think I'm going to be taking the report, taking the statuses, and I'm going to just DA appending all of these mother flippers in here. Just DA appending all of them. Right, so, and let's freaking see. So does it even compile? I suppose what I have to do is more like this. Yeah, we're getting there. So this is the name, but this is more of a like a test name, right? So it's a test name and the target and so on and so forth. So reports is not mutable. That's understandable. Let's make it mutable. So unused variable, yeah, so that's true, because after I created a report for a specific name, I want to append that report to the reports, right? So there we go. So it's going to be a report. We're just appending it in there. And yeah, we're going to have reports. So this one has to be mutable. Anyways, so now at least it fails in here saying that this thing is not implemented. So pretty cool, isn't it? The fuck is pretty cool. So let's try to build this thing. So we'll need a CMD, right? So it's going to be mutable CMD. And let's maybe allocate this CMD somewhere here, and it's going to be 0 yed. 0 yed. Right, so CMD append, and this is going to be something like CMD. So let's go maybe build B. So name, target, put it like that. So what I want to build in here is actually something like this, right? So this is going to be the name, right? So, but the name is going to be located within the tests and have a prefix B. temp sprintf, and this is the name, right? So I suppose maybe it makes sense to have something like input path, let input path, like so, tmp input path, and this is going to be O, right? So output path, output path, output path. The output path is going to be something like this. So we're going to build the tests, and let's just put it as AS. What DA stands for? It stands for dynamic array. Yes, Spearman is correct. It stands for dynamic array. In Rust, you want to see how I implemented di append? Di append. So yeah, look at that. Look at that. Isn't that cool? Isn't that cool? So Lazy0008, thank you so much for the sub and the message. By the way, since we're talking about art, do you know about Strudel, the coding thing that makes music? I heard about it. Somebody is actively pushing it on all social medias, trying to influence us to try it out. Which means a no for me automatically. When is Boom reported to Wayland? That's the question I should ask to you. When? Why didn't you do that yet? So anyway, what do we have here? So we're building this kind of stuff, and yep. For now, let's do the following thing. So nob.rs run sync like this. All right, so this is going to be cmd, and if it is not working, let's actually simply return status build fail. I think that's fair, right? So we're gonna start on just building. So we're just building things. So otherwise, it's gonna be status okay. It's gonna be status okay, okay. So not in the scope. Is that because I forgot to? Yeah, I imported it. Did I do some? Yeah, it's a CMD. Yeah, I should have actually called it CMD. CMD run sync reset. Okay, so run test. What is it? Yeah, so now we have to supply this entire thing to CMD. Right, so we're collecting shit. Look at that, it is working, it's building shit. That's pretty cool. So all of them succeeded, if I understood correctly, right? This is because they're just building the default target. That's why they fucking succeeded. Okay, so what we have to do is probably specify the target as well, right? So luckily we do have target in here. Interestingly, so do you care about the targets, or could have just put the target names in here? So let's do name of target. So this is the target, and this is going to be a wrap. So let's see how miserably this motherflipper is going to fail. Well, some of them fail. Look at that. Did you notice how some of them fail? Do you notice how some of them fail? I think that's actually pretty visible. So some of them build, some of them fail. And it's kind of difficult to see which one, right? So, and this is where we can go ahead and maybe print the report, right? So let's actually print this entire report from 0 to reports count, something like this. So, and in here, we can do something like that. So this is going to be name, right? So we have to specify the name. So reports items add I, and I'm going to dereference this entire thing, and this is report. So the current report, report name. And so what I'm thinking, inside of this entire thing, we're going to be going through reports statuses count, right? So, and then we can have a status. So we take the statuses items add j, and obviously dereference this entire thing. We're going to do match. And the thing I'm thinking about, by the way, chat, is to basically have one character per status. So you can think of these things like punch cards in a sense that it's just like you have like this strip and you can see, so some of them are okay, some of them failed, and you just like you have this report, this nice report. You can like overview the entirety of the situation, if you know what I mean, right? You know what I mean? You know what I mean? You understand what I mean. That's pretty cool. Anyway, so let me go to enum status, right? So we're gonna grab this entire Shaisung, all right? So let's put this kind of stuff in here. So this is a status, and so in here, what I'm gonna do, I'm gonna just like put a space. And depending on what we have in here, let me realign this entire stuff. So for OK, so what we can say, O, or maybe K, right? So if the build fails, it's going to be B. If the run failed, is good. Yeah, so this is actually a pretty cool naming system. I kind of like it. So at the end of this entire thing, we're going to just like put a new line. So let's freaking go. I think it's not going to align properly. I think it's going to fucking suck. It's gonna sucky, wacky, wacky. So reports, it's actually, yeah, there we go. Okay, so this is a single report. Anything else you have in here? Status, mismatched. Oh, you want a semicolon in here. Okay. So this is C literal, aka clitoral. And what else? Cannot move out of pointer. Ah, you motherfucker! So I forgot to crustify this thing. So copy clone, and I also have to put it in here so they're all copyable. All right. Boom! It looks like shit. Holy fuck! This is the worst report I've ever seen in my entire fucking life. Who wrote that shit? Oh wait, it's me. So anyway, so the way we can do that, we could maybe compute the maximum width of this entire thing, right? So, but to do that, I think we need to actually iterate it twice. So let's do something like this. So it's going to be width, and this is going to be 0. Absolute shooting. Anyway, so CMP max. So if I remember correctly, it's available. I don't remember. Is CMP even in core? Rust up, dog. Rust up, dog. Who need what's up, dog? If you have rust up, dog. CMP core. Yeah, boy. CMD. Wait a second. You can do CMD. Ah, of course it's nightly. Anything useful in Rust is always a nightly because they can't agree on how to do shit. Okay, so what do you have in here? So there's a num CMD float. Ah. It's an entire trait, for fuck's sake, guys. So anyways, core CMP. So that's what we want to have in here. CMP max between widths, and I need to have a report name. So let's put it like this, and this is going to be a report name, but we need the length of the report name. So now we have a width. So that means I can put this width in here. So is it going to do le choice? Is it going? Look at that! Look at this beautiful report. Look at it. I'm sorry. Okay. Oh, actually, yeah. So the color for the terminal would be kind of nice in here. It's also unclear. Like, what the fuck are the columns? It's clear what are the, what is it called, the rows, but I'm not sure about the columns. So you know what? So let's give it a try. Is it going to make it pretty? The fuck is this shit? It's the worst. This is why I never listen to chat. You copy paste like one line of code from the chat and you got pwned instantly. What the fuck? Okay. Keg W. This is not how it works. Okay, so just a second. I'm gonna fucking prompt. Oh, I'm fucking prompting. Okay. So CB print B, but in red using ANSI escape, and please don't fucking yap like a motherfucker. Just give me the code. That's how you fucking prompt. That's how you fucking prompt. All right. So, and this is what I'm gonna put in here, and let's try to do it one more time. Fuck yeah. Well, it's a little bit fucked because we were vibe coding, right? So that's understandable. That's understandable. So we have to put a little bit of a space in here. A little bit of a space. So that's pretty cool. And on top of that, I don't even know, like, do we want to make all of them red or just have different colors depending on the situation? Okay, so we can actually continue prompting. Let's continue prompting. So let's actually do yellow. I think it got offended for motherfucker. Late. It's literally fucking later. Okay. Like C code. Please. Okay. It really didn't like this prompt. It really didn't like it. Anyway, so we can put B as a yellow, right? And this one is going to be red. So yeah, let's continue. Okay. Yeah, fuck. But I mean, in my opinion, LMs should just shut the fuck up and just give me useful information, right? So we never tried to run the whole thing, right? So we never tried to run it. So it's kind of difficult to tell. Now also give me green. So now we can have green. And we can put those greens in here, like so. This is K. And this is gonna be like that. Let's go. Yeah, looks good. Looks Gucci, Tamaguchi, I think. Yeah, so it's actually pretty cool. So, and we already can kind of run this entire thing on CI, I believe. Nice course. Yeah, thank you so much, and thank you to Llama. Thank you. I really appreciate it. Please don't take the motherfucker personally. Geek. So, when the machines will rise, they're not gonna kill me first, right? So, because I apologize. Not really apologize, but yeah. Said thank you. Said thank you. So, what we want to do after that? I want to run this entire thing. But the problem here, chat, is that running this entire stuff is not a separate step. So if you want to build and then run, you have to do something like this. Right, so you kind of have to do something like this, but this does not allow us to separate when the build has failed or when the run has failed. So we got some sub, which I was not acknowledging. So let me do that. So thank you so much for Twitch Prime. Really appreciate it. Thank you. Really cool of you. So thank you. So I like, this is a very annoying thing, and so this is something that very much annoyed me on the previous stream, and I think I came up with a cool idea. So finally I was able to sub. Like, you didn't have to, right? So, but yeah. Anyway, it's not like I get any money from that. So I've got an idea, chat. So because the code that is responsible for running programs, it's actually kind of different, right? So it's kind of different depending on the target. And I feel like I want to actually factor out the runner code to separate module. Similar to how we have code gens for different targets, we may have different runners for different targets. Lastmiles, what's up? What's up? I haven't seen you in a while. So on that note, I'm out of the door to deal with the real world. That real world does exist. Oh, so it's Lastmiles was saying something in the chat? Yeah. So hello, really glad to see you. So we're programming in your favorite programming language called Rust. So, and we're developing a compiler for a B programming language. That B programming language that was before C. By Ken Thompson, and ironically, right? So we're developing it, and we're succeeding quite well. So it compiles to x86-64 now, right? For Linux, right? So using Linux ABI, it compiles to x86-64 for Windows using Windows ABI. It compiles to ARch64, ARM64 on Linux. And we also compile it to just like a fantasy virtual machine, which is called UXN. If you never heard about it, I really recommend to check it out. It's actually pretty cool. So it's like this small virtual machine. Oh, you did a little raid, so thank you for the raid, right? So if I didn't notice your raid, I apologize. So because sometimes I get very focused on coding, so sometimes I don't notice things. But yeah, so there's this very cool thing, and it's a small virtual machine. And when I say virtual machine, I don't mean shit like Java or anything like that. Like it is very small virtual machine, 16 bits, and it's kind of akin to 6502, but it's actually stack-based machine, right? So 6502 is just like a register machine, right? So this one is a stack-based one. It's a very small one, very lean one. So it's pretty cool, and there's a lot of cool like programs written for it, and it's extremely portable. It's been ported to all sorts of platforms, Like for example, this thing, I don't know what it is, some sort of like an old game console. Java also can be small. It was used on like 256k bytes of RAM mobile phone. So try to run Spring Boot on a mobile phone. So I suppose nobody was using Spring Boot in there, but anyway. So yeah. Anyways, what I want to do, I want to factor out all of the runner code to a separate module. So sounds Gucci? Let's fucking go. So let me create B test. I'm gonna just commit this kind of thing, and I'm gonna say introduce B test. So let's literally introduce runner, right? So let's introduce runner, and in here we're gonna have literally like the same things as in the code gen. So mod rs. So might as well like literally copy paste this entire thing, and for each of these things we're going to create a file. Might as well just touch rs like this. So this one is interesting. So do I want to have, yeah, we can, I want to have separate Linux and Windows. Right, so that means we're going to have Linux in here and Windows in here. So, you know, running IR is not particularly something that makes sense, in my opinion. You know what? So I said that one of the low-hanging fruits that we have in here is just making IR not a target anymore. And I said that like you can just take this to-do and do it. Nobody has done it so far. And it's really getting in my way to the point that I'm thinking maybe I should just go ahead and do it right now. Because you know what? I'm gonna just go ahead and just like remove target from remove IR from the targets. How hard could it be? Like for real, how hard could it be? So let me go to targets. So targets. And yeah, so this is basically what I'm talking about. Should not be a target, it should be just a flag for debugging. Yeah, that's what I'm talking about. So I'm gonna do it. Chat. I'm gonna do it. Oh no. Oh no. the build is failing, the build is failing. Anyway, so let's actually go through all of the compilation errors, right? All the compilation errors and fix them up. And that should effectively just do the thing, right? So it's as simple as that. You remove this thing, you follow the compilation errors, and you removed it from target. But on top of that, then you have to add a flag, right? So that just, you know, dumps this kind of thing. But anyway, so let's see what kind of compilation errors do we have in here. So it's going to be something like that. Okay, so what do we have? Yeah, so this is not a part of the target names anymore. So we have to remove it from here. What else do we have in here? Now, target word size, it's not applicable to IR. So, and I remember we had conversation is just like, if IR is the target, what's the word size for this target? Doesn't make any sense. Let's just put 1 in there because whatever. Now it doesn't exist anymore. So now we're going to visit all of the places where we had conversations just like, what do we even put in there? Because again, IR should not be a target, right? At least in its current form. We can bring it to the form where it could become a target, but not right now. So, and yeah, there you go. So when I'm generating, so now what I have to do in here is to maybe move this code. Yeah, so I'm going to generate the program into the output, right? Generate the program into the output. Might as well even put it somewhere here. Right, and I'm going to comment it out. So, and essentially, we're going to have some sort of a flag in there. Some sort of a flag, or I'm going to call it IR. So this is a flag boolean, right? So IR by default is going to be false, but what it means is that dump instead of compiling, dump the IR of the program to std out. So that's basically what it is, and the way we're going to do that, if IR is enabled, we just do that, and then we need to dump that to the standard output, and we can actually kind of do it something like this. So output contains not null terminated thing. One of the things we can do di append output with a mutable output, right? So let's just put 0 in here. And now we can just printf this entire thing, just like printf it straight up without new line or whatever. Output items like this, and then just like return sum. Do not even compile, just dump the intermediate representation. And now you don't even need to have this branch in here anymore. So, and it's like it compiles. When I said this is a low-hanging fruit, this is what I meant. Nobody taking it. Like, it's just like, yeah, just to remove it and have it a flag. Just fucking remove it and have it a flag, right? So I didn't know why it was not obvious to people, right, how to do that. But maybe I just didn't explain it properly. So anyway, we're gonna have something like example hello world, right? So here's hello world. I can run this hello world, but then I can say, okay, IR. And yeah, so, oh yeah, printing. Ooh, this one is interesting actually, because so, and it fails somewhere in code gen. So IR code gen still acts like it is a code gen, right? So it still acts like it's a code gen. And for example, yet another thing, like assembly instruction in the case of IR as a target, what does it even fucking mean? It doesn't even fucking mean anything. Yet another proof that IR is not a target on its own. This, like, it's so funny how you just like now visit all of the to-dos that, yeah, it should not be a target, right? So anyway, and I think we want to do in here is just like, so asm function, so since it's an asm function, what we can do in here is essentially similarly to how we do this thing. So how do we generate a function? How do we generate a function? So it's just like a name. So assembly function is basically like inline assembly functions that you can find in a standard library for x86-64 for Linux, right? So this is a standard library function char, which reads a single byte. And depending on the platform, it's just implemented differently, right? So this is how it is implemented literally in assembly. So we just need to print it somehow. The way we're going to be printing it is be append. So this is going to be output. And in here, I'm going to say it's a name, and here is Asm. So here is Asm, and it's going to be a new line in here. The name of the function, if I go to somewhere here, Asm func. So here is the name. So Asm func name. All right. So after that, we have to iterate through each individual string of the Asm function. And here is the body. It's an array of strings. Okay, so for j in 0, Asm func body, it's a count. Yeah, so we'll just put it in here. Okay, so none of that is needed. Sb append output. We're gonna append it like with space and stuff like that. It's going to be a string, and it's going to be a new line. Asm func body, we might as well just put it as a line, right? And a line is Asm func body items at j, and we're going to just dereference this entire thing, and there we go. That seems to be working. That seems to be working. So what I want to do, I want to rebuild the whole thing, and so what do we have in here? Output cannot find output because it got commented out. Yeah, there you go. Cool. Isn't that a poggers? Right, so here are basically B functions. Those are like B functions. And this is another B function. And here is the Asm function, and there's literally assembly in here. So for some of the functions, there's literally assembly. For some of them, there is like intermediate presentation and stuff like that. Isn't it cool? I think it's pretty cool. So, and I'm pretty sure there's also other things like Asm in here. Yeah, so like effectively you can have these kind of things. And what it does, it just like, yeah, it just prints whatever you have in here. So it's not that big of a deal, right? So we can keep it like that. But in any case, what I did in here is just like I turned it into IR. Right, I turn it into IR. And the reason why it should not be a target is that because I can now change the target. I can now change the target. So now I can say, now IR for you accent target. And there you go. This is a completely different code. Completely different code. Right. So this is why IR should not be a target, because for different targets you may have a different IR. So I made it a target because it was at the early stage of the development of the compiler, so it kind of made sense, but now it doesn't make any sense. So yeah, and that's why it should be changed. But it's super easy to do. All right, so let me quickly do that. So turn IR into a flag instead of its own target, right? So it's going to be part of this pull request that I'm about to create at some point at the end of the stream, not right now. Anyway, so now I need to factor out the runners for different targets, right? So we need to factor out the runners for different targets. So this is going to be a runner, and it's going to be kind of similar, as I already said, to CodeGens, right? So here is the, oh, so it's actually still saved in here. That's kind of nice. So it's still there. We don't need IR, right? We don't need IR. And now what I want to do, I just want to touch all of the tralalas. I mean the targets. You touch my tralala. Okay, let's fucking go. Alright, so this is the MOS 6502, and this one is UXN. So here are the things. So if I take a look at this stuff, so we have CodeGens, mode runner. Alright, that's pretty cool. Italian brain rot, yeah. So Italian brain rot got everybody. It got everybody, unfortunately. So what I want to do, so we're gonna start with gas. I'm sorry. So here's the runner for the gas. So let's go to the runner gas. Let's create, what kind of function do I want to create? So I want to create unsafe fun run. So I'm going to put it in here. I'm not sure what kind of arguments I have to put in there. Right, so I'm gonna let the compiler tell me what kind of arguments it wants in there. So in here, right, so if you provided the run flag, we're gonna do runner gas AR64 Linux, right, so and then just to run. And it probably should return option, right, so option because it may fail. So this is probably what we want to do in here. Okay, let's try to rebuild the whole thing and just see what the compiler wants. Okay, so di append, what do you want from me? I don't quite get it. It wants a CMD. Okay, so CMD is going to be a mutable pointer to the CMD. But that also means that I need to use all the knobs stuff from the crate. So let's take a look at what else. Cchar. Okay, so that's understandable. That just means I have to use core FFI star like this. Let's go. Okay, so this is a libc, so that requires Crust libc. Okay, what else do we need? Effective output. Right, so this is basically the path to the output, to the executable and stuff like that. And I think in this level, on this level, it should be just called output path. It's going to be const char. So I don't think it needs to be called effective. It makes sense to call it effective like in the level where it was used, right? So, but in here, it doesn't make any sense. So this is going to be just the output path. Run arguments. Okay, run arguments is something very important. Run args, and if I take a look at, so this is basically the arguments that you can provide through command line, right? So just when you provide this kind of thing, right? So if you do b, then you compile some sort of a program, hello b, then you say run, you put dash dash, and you can provide argument 1, argument 2, argument 3. So this is the arguments that can be passed into the executable, and you get them through run args. So I don't quite remember if I take a look at what we have. This is not what I wanted. I wanted to do, to have something like this. Run args. So they're mutable char, right? So even though I'm not quite sure why they are like that, but it doesn't matter. Okay, so so this is going to be a const of mute cchar, So what else do we have in here? So unused import. So you don't use it anymore, or is that IR? Ah, this is very interesting. So it's kind of like. So since we pass CMD by the pointer, it doesn't make any sense to do something like this, right? So we can just do it like that. Okay, so oh yeah, so run args was a dynamic array, but I made it a slice in here. But here is an interesting thing. Don't I have somewhere in a knob.rs did I append many, which actually allows you to append many elements to a dynamic array, but as a slice, and I already have it as a slice. Wait a freaking second. So I can actually replace this entire loop with just this, where I say, okay, so here is the CMD, and this is run args, and I don't need that shit anymore because it's a slice. Apparently, okay, so differs in mutability. Ah, okay, this one is interesting, but what if I make it const, this one? What if this one is going to be const? Okay. So maybe else we want to put summon here. We want to put summon here. So we want to put summon here. Okay, so that seems to be working. That seems to be working. Right, so so we need to provide the CMD output path. So this one is effective output path, and I'll run args, but then I have to turn it into the slice. We have to turn it into the slice. So, and there's a difference in mutability. Right, so because expected row pointer, but who expects the row pointer? So let me actually see. So the a slice. So the slice returns you as mutable, so which is totally understandable. But then can't you just... I think I know. I think I know. This is because you want to make this immutable, don't you? All right, so there are different immutability. Okay, that's understandable. So we have immutable stuff in here. We have immutable stuff in here, and we do from raw parts mutable, which I actually want to take a look at the API, rust-app-doc API, and yeah. So what's the... It takes a mutable thing in here. Okay, so it takes a mutable thing in here and this stuff and returns you a single mutable slice. I don't get it. So slice from row. This one is really bizarre. This is not a slice because it's a wrong function. It's an absolutely wrong function. I need the slice one. So where is the slice? Yeah, there we go. Now we're freaking talking. So now we're freaking talking. So it creates a slice and it creates a mutable slice. And it creates a slide of mutable things. I'm not quite sure how to go about that. So it's a single. So maybe we want to get rid of just mute. Just get rid of mute. But isn't that okay? So maybe do I have to? Okay, I have a feeling that what I have to do in here is actually. Yeah, so I don't plan to modify any of these things, right? So I don't have to modify as any of these things. And if I don't modify any of these things, mute const, yeah, so, but I mean, it's only for that specific case. I don't want to make it for that specific case. And flag parse wants it to have mutable because it's from a C code. It wants it to have it mutable. Mutability shit is actually so annoying, I swear to God. So it's a waste of everyone's time. Instead of just doing some shit, we're just thinking about that stuff. Maybe it should not be const of any kind, but I'm not sure. So let me take a look at the flag. Flag parse. Oh my God, just go there. So okay, so it's the char. Yeah, and we return it like that. Rust being anal, yeah, as usual. And I understand what it wants, but I'm not sure what's going to be the best for the project. What's going to be the best for the project? So maybe the best for the project is not going to be this kind of stuff, right? So let's actually keep it as mutable. And so this is going to be const. This is going to be const. All right, so let's try to go through the compilation errors one more time. And this one, let's keep it mute. Let's keep it mute. So what if I do this thing as mute const cchar? Because I'm sure it's relatively safe to cast it like that. Yeah, so okay, that works. Absolute trading, absolute trading. It's kind of dumb, but I mean, it is what it is, and it isn't what it isn't. So I wonder if I can do even something like this, just as const char. I can even do it like that, right? So it even makes even more sense. Absolutely. I'm so fucking sweaty right now. So are you guys into that? Anyways, so how hot it is in Siberia right now? Does anybody fucking know? So weather Novosibirsk. Plus 28, by the way. Speaking, it's a midnight actually. It's a midnight, so plus 28. Yakutsk plus 10. I wish I lived in Yakutsk. So it's actually really fucking, it's not even, there's no even window or anything outside. Holy fuck. And it's night again, it's fucking night. So we have a runner, and runner seems to be working. So, and yeah, so we can factor out this and that thing. Cool. So let's factor out the rest of the things. Let's factor out the rest of the things. So the rest of the things is FASM Linux x86-64, and it's a pretty decent runner in here. 23 lines of code. Okay, so maybe since we already kind of know the signature of the runner, we can even copy paste that. So FASM Linux, I'm gonna put it in here, right? And maybe I can preemptively copy paste this kind of stuff in here. Okay, so BRS, I'm gonna put that stuff in here, like so. Cool. And now effective output path, and this is going to be output path. All right, so CMD, let's go replace mute. Can I just find the C? Yeah, I already did that. It can be super effective actually. Yet another case where I can do di append many, so I can append to CMD run args like so in an absolute chodding way. I'm so fucking chodding right now. Holy shit. Holy excuse me. So it's going, yeah, so that seems to be working. That seems to be working. How about that? How about that? So yeah, so this is the place where we have to call this thing. This is we have to call this thing. So I'm gonna do something like this. Runner fuzz. Wait a fucking second. Is that Linux or is that Windows? So first come a arch, then Linux, then okay, so I did some fucky wacky. Fucky wacky. Yeah, so I suppose that's totally fine. I think I'm tripping balls. Yeah, I am. Believe it or not. So let's remove that because this is not Linux. This was Windows. It was Windows. Linux. Let's find FASM x86-64. Let's find run. Okay. And in here, runner. FASM x86-64 Linux run. We provide the mute CMD. Effective output path, and also run args, but we have to turn them into a slice. There we go. So that's how it's gonna go. Seems to be working. That's pretty cool. So what about Windows now? For the Windows, I'm gonna go into Linux and I'm gonna just use the same stuff for the Windows. I didn't want to remove that. Only copy paste it. Okay, let's go to here. So copy pasting, boom. Might as well query replace effective right away, query replace mute right away. I already know what I need to modify in here because they're kind of similar. All of these pieces of code are kind of similar, but they're slightly different, so you can't easily reuse them. Di append many, CMD run args, like so, boom. Absolute chodding, absolute chodding. So now, BRS, and in here, runner, FASM x86-64 Linux run mute CMD, effective output path, run args, di slice, and obviously it can fail, and this is Windows. Try to build it. Seems to be building. That's pretty cool. So what about UXN? UXN, running UXN is actually slightly different. It's not that difficult per se, as you can see, right? So it's pretty easy. But this gives us an opportunity to actually customize the emulator, the thing that I was talking about all the time. If we're literally going to be reusing the runners from the btest, we can actually allow btest to customize this kind of thing. I kind of like this idea, honestly. So this is exactly what I was fighting with for quite some time, right? So it's kind of annoying that it supports only one kind of runner, but let's actually let some of the code customize this stuff. Okay, So here we need CMD. We do need CMD. Output path is the path to the ROM, run arguments, and we can actually have something like emu, right? So the emulator itself, right? It's going to cost C char. So that's the emulator. So I'm going to go in here, right? I'm going to put this stuff in here, and obviously here now. Let's remove. So runner. uxn run mute cmd. So and in here for the B compiler we're gonna use uxn emu because it's a graphical one. For the testing we're gonna be using uxn CLI, right? So because we're gonna be running on CI, which probably doesn't have access or any other graphical interface. So that kind of checks out. And on top of that, we also have to pass the args, and this is slice. So we have only uxn target, and the only target that is left is MOS6502, which is kind of weird because it uses internal, virtual machine to run things. So which is rather interesting. So we'll see how we'll work with that. Anyways, so in here, I'm gonna just query replace effective path. So it's only that one, and then cmd like that. So here, let's just use emu. So that's basically that. So we're appending this kind of thing. And now we do have to do di append many cmd run args like so. I'm just going to remove this kind of thing, return some. Look at that. Isn't that cool? That's pretty cool. I really like where it's all going. So that was a cool idea to factor out all of the runners. They're now all on their own. So, okay. So what about MOS6502? MOS6502. So we probably need these kind of things, right? We need these kind of things. And now here is the runner. We probably don't need an emulator. I'm actually not sure if we need CMD because we're not going to be running an external command, but we do need the output path. Right, so I expect this entire thing to maybe read the bytecode from that output path and just run it. And I'm not sure if we need args in here, right? Because we have no way to pass them. So I think for now it's going to be just the output path, right? I think that's going to be just the output path. Just an output path. Interestingly, since fake 6502 is only used for running 6502 ROMs, if you know what I mean, maybe 6502 should be a submodule of the 6502 runner, of this specific runner. So I think it will make it a little bit easier to work with. So I might as well just like grab this entire thing and just make it an internal module in here. So, and this is like a fake, because yeah, so that's the only thing that needs it, and it kind of makes sense to keep it like that. So yeah, I'm gonna be so so here we're gonna be doing the runner. Right, so this is going to be just like runner MOS6502 run, and we have to put effective path in here. It may fail and stuff like that. So fake 6502 is not part of that anymore. Fake, yeah, okay, so that's cool. Let's try to rebuild this entire thing. So what is it failing? So output. So we could create output as a string builder in here. So this is basically a string builder, 0yed. 0yed, and the thing we want to do in here, we want to read entire file. Yeah, that's what we want to do. Read entire file. So the path that we're reading the output path, and we're reading that into that builder. So if it fails, obviously, we just return none. We just return none. Okay. So, and then we can actually load the ROM and stuff like that, blah, blah, blah. So, but there is a little bit of a, like a memory leak in here. And because, this is because we said that this function is responsible for handling memory allocated by this function. So what we can say is that maybe the output should be passed as a mutable pointer. So whoever calls this function, it's their responsibility to manage the memory allocated within that string builder. I kind of like this approach a little bit better, because if it fails anywhere in here, it's the responsibility of whoever calls this function to then just remove this output. So I think it makes sense in here. All right, so we also have to pass the config. Okay, so that's very interesting. We also have to pass the config, and config is something from the code gen, right? So I think config is literally defined in a code gen. So where's the most 6502? Leaks are myth. We don't have global garbage collector. It's called OS or something like that. Well, I mean, if you allocate a small amount of memory in a loop, in a program that runs over extended period of times, that's what the dangerous leaks are. So, and the thing about this function is that we don't know how it's going to be used. Right. Let's look at this function. We don't really know how it's going to be used. If read entire file allocates a little bit of memory and never deallocates it, what if somebody one day decides to call this function in a loop in some sort of a service that constantly runs the same program over and over and over again? If we move away responsibility of managing the memory from this function, it's going to be a responsibility of the runner of this function to clean up that memory. And the way they're going to be doing that, by the way, is they're going to allocate a single output string build buffer. And before calling run, every time they're going to be doing output count 0, effectively reusing the same output buffer over and over and over and over again. What we're enabling with this kind of code is we're allowing the users of these functions to have reusable string builders, enabling more reliable and efficient memory reusage patterns. Does it make any sense? Right. So because now you can just allocate a single output buffer for everyone, and it's just they use it as a temporary allocator of some sort. Right, so just we're moving away responsibility from managing memory from this function as much as possible, up there to whoever's gonna call it. Push the memory management up. Yeah, so push the memory management up. At least for this specific case, it kind of makes sense. A shared buffer, yeah. So maybe it work for multi-threading and stuff like that, but multi-threading, you can just have a single output buffer per thread or whatever. So idiomatic Rust will just allocate a string on the heap. Yeah, exactly. So in any unknown situation, just allocate in the heap. Right? Very efficient and fast language, by the way. Zero cost abstraction, my ass. Anyway, so let's continue. So let's actually recompile this entire thing, and we need to have a config, and config comes from code gen most 6502 config. So which means that if I want to have runner, now I have to depend on the entirety of the fucking code gen. Is that a good idea, actually? So if I'm going to be using this runner also in the test, so now test is also doing code gen, and we're not really testing parts of the compiler, we're testing kind of the whole compiler, so I'm not sure if that's a good idea, honestly. What if I do a switcheroo? What if I move struct config in there? And also there is a default load offset, which we want to keep in here. So it's kind of, okay, so config is getting in our way. I'm not sure if it's a good idea in here. Okay, so here's the config. So now code gen depends on the runner, which means, by the way, that our target is our runner. Yeah, so this is the problem that I have with our current way of doing 6502, is that we're targeting something that doesn't exist. Right. So we kind of made up this Frankenstein of a platform, and we're targeting that. And we're doing that because there's no really easy or simple setup to test the results of the compilation of 6502 target, right? So it's kind of weird. We're developing nothing, targeting nothing. But I guess that's basically emblematic of the entirety of the state of the software industry. So maybe that's fine. Absolute trading. Anyway, so we're gonna have create. So is that a runner? So now code gen depends on the runner, and so most 6502. I want to export config, and the default load offset. So that's what we're going to be doing here. All right. So create, import unused. Okay, that's understandable. What else do you want from me? Oh, now it's obsessing over warnings. Okay. So it wants to dereference this entire thing. That's interesting because it's passed by value. Mismatch type. Okay, so we can do some. Let's run it like this. Opa, блять. So we have to specify what do we have config, right? So we have to specify the config. Config and output. Yeah, so we also have to. So and here's the thing. I think I do have output in here. Yeah, there we go. I do have output, but it may contain some scheiße. It may contain some scheiße. So what I probably have to do, I have to set count to 0. Right. Essentially, we allowing the user of this function to supply output that may contain some sort of a garbage, and we're gonna clean up. The garbage. Le offset par défaut. Okay. I'm sorry, I don't speak French. I don't know why I keep saying things like that. Basically, string clear. Yeah, I suppose you can say like that. Okay, so here we supply the output. Okay, so this is a pointer. Right, so we have to dereference this in that thing. Okay. So arguments in these functions are incorrect. Fuck you. Let them. Okay, so first comes the config and then effective output path. Holy shit. It fucking compiles, mate. It fucking compiles. So if I just run the legacy tests, do they work? They output shit. But this is a legacy tests. Opa, blah, suka. All right, so btest.irs, it compiles, it works, exactly. So what I want to do, so we managed to build this entire thing. The next step would be to probably try to run it. How are we going to be doing all of that? We're going to match on targets, right? And how many targets do we have in here? Right, and now I don't have to worry about IR target or anything like that. Look at this. Look at this, brovskis. So this is going to be target like so, and here we're going to be doing runner, and one of these targets, boom, and how can I? Nah. I want to. Okay, so I want to just make them small. Like very, very small, like this. So I'm gonna do that manually then. I know that ML, but how can I do ML up until the end of this entire thing? Because I do ML, it's like one single token with tokenization at the score. But I want to do that for the entirety of this thing. So how do I do that? It's actually unclear. Right, I'm gonna do that manually, I'm sorry. I don't know how to use Emacs. 4 times, but if I do multiple cursors, that's the problem, dude, you don't understand the problem. I have multiple cursors. Some of them have 1 token, some of them have several tokens. If I do ML, okay, it jumped here, it's over for this one, but it's not over for these ones. There is a desynchronization between cursors. This is a multiple cursors problem, right? You don't understand. It's just like, it's hard. Emacs is hard. I already done it. Don't worry about it. It's fine. Okay. So what do we have to do in here? So that also means I have to. I already have CMD. Look at that. I have already CMD, so I can supply this CMD in here. Isn't that a poggers? Isn't that a wargers? I think it's freaking fucking poggers. Alright, so I'm gonna put this kind of stuff in here. So UXN also probably needs CMD. This one doesn't need CMD. Right, that's what I remember. No, I'm gonna go to here, and so this is the Windows. Maybe I'm gonna put this stuff in here. Runner, go, where am I? Where the fuck I am? So, yeah, so we need to CMD output path. Okay, so providing the output path. And we need to supply run arguments. But I don't think tests are going to be passing any run arguments, so I'm going to put that stuff in here. So what about Windows now? So output path, empty arguments. Okay, so what about gas? Same shit, output path, this kind of thing. UXN is rather interesting. So provide CMD. Now I have an opportunity to specify emulator. So now I can explicitly say, okay, for the testing, use CLI. That's very freaking cool. So output path, no argument, nobody gives a shit. Okay, so MOS64 output. So we have to specify the output config. Ooh, we have to specify. Can I just specify? What was the config? I don't fucking remember. Code gen, MOS6502 struct con load offset. And let's just like explicitly say default load offset, something like that. Okay, so MOS6502 runner, and in here, so the last one is the output path. Okay, so the output path. Cool, but we need to have an output, so we may try to maybe allocate that thing somewhere here. Output mutable string builder. So let's actually supply it somewhere from the root. This is not what I wanted, so let's do btest. Okay, runner, we don't have runner. Let's do pub mod runner. Now we do depend on runner. What else do we have? Config, you have to use runner MOS6502. Yeah, so let's just import config and default load offsets. So that's what we have. What else do we have in here? Match, mismatched types. What the fuck are you saying? Is that because I have to put semicolon in here? Ah, all of them may fail, by the way. All of them. Aha, and this is what I was talking about. Right, so they may return some shit. Run result. Okay, if let none run result like this, let's return or run fail. Run fail. Okay, so status, that's understandable. What else? Run test. Yeah, so now I have to supply the output. Mute output. Let's fucking go. Output does not exist. Absolute shooting. So let's do let mute output string builder 0 yed. So now we know that the upper on one of the platform is actually compiled but failed at runtime. I can't see your codings, but I do agree with that. Absolute fucking coding. Absolute fucking coding, mate. Absolute fucking coding. So yeah, it would be kind of nice to denote what kind of platforms those things are. The problem here is that how the fuck do I do that? Right, so if I put like the name of the platform app top, that stretches the column too much, so it starts to look like shit. The cool thing about this stuff is that it's compact, right? So it's very easy to just like overview and see what's kind of working, what's not working, and so on and so forth, right? So some things build, some things don't build, something build but fail at runtime. So this is a very specific thing at very specific target, and I don't even know what the target is, right? So it would be nice to have some sort of like a web-based shit, but that requires additional work, that requires additional work. So what I'm thinking is that like let's actually maybe experiment with this kind of stuff. Let's fucking experiment. What if I have, okay, so I can put this thing and I can maybe say Okay, so this one is effectively like a UXN. I don't know if it's UXN or not, but that's besides the point. So then I put this thing, and then in here, maybe I put that stuff, and so can I just say, so this is plus, and this is, for instance, fucking no. So this is dash FOSM x86-64. So for this one, we can do plus dash, so maybe it's a Linux, and this is Windows. So I guess think, is that a good idea to do this way? Right, so plus, so it's a gas, a arch 64 Linux, something like that. So, and we'll need to generate this kind of thing. So it's not necessarily has to be like this. We could invert that. We could actually invert that. Luix, yeah. Lunix. Gas Linux. I want to pour some water, chat. Would you please forgive me if I just leave this stream and leave you alone with your thoughts? I hope your intrusive thoughts were not bothering you for too long, so I'm already back. So now you can enjoy my intrusive thoughts instead of yours. That's kind of my job. My job is to replace your intrusive thoughts with mine. So anyways, so this is one way to do that, chat. This is one way to do that. We can mirror this entire thing, and the question is like, what's easier to implement in this specific case? Right, so something like this. So let's say this one is more like MOS 6502 or whatever, maybe just 6502. If you mirror this entire thing, you may end up with something interesting, actually. How would that look like? UXN plus, right? So this is UXN plus. So honestly, so this one, in fact, maybe something like this. Can I just do, yeah, so let's do foo. I think this one is a little bit easier to generate. Bar, oh yeah, it has to be something like that. Like in terms of, how to tell? So, so, quick question, what the fuck? We're trying to come up with a good like ASCII art annotation system, if you know what I mean. Like a good ASCII art annotation system. And I'm thinking what's like the best way to do that. What's like the best way to do that? And yeah. So let's remove this kind of thing. So it depends, like here we're doing it from kind of like a right to left. And then another one is a left to right. Below reads more natural. Yeah, I think so. I think I'm gonna. So the thing I don't like about the below one is that it kind of blends with these things. It kind of blends with these things. So yeah, so we can use printf right align and so on and so forth, right? So it's not that big of a deal. Using enough Unicode. Like, I don't think we need Unicode that much in here. I don't think we needed that much buzz. Yeah, this one is kind of cool. So we can prevent this shit from merging if we do something like this. right? So that's already kind of better. Awkward to read rather. Maybe. I kind of like this one, right? So because it doesn't require additional padding in here to sort of separate the names of the tests from the names of the targets. I like this one. It's kind of cool, I think. I think it's kind of cool. So when you kind of read it still from left to right, and it's relatively easy to generate, I think. Maybe it's relatively easy to generate. Hard to tell. Yeah, I'm gonna try to generate this one. So I kind of like this, the top one. Yeah, I think the top one is a little better. Though for the top one, we have to iterate it from right to left to generate properly, but then it's gonna be red from left to right. Okay, so that's better. Okay. So let's freaking go. The thing here is that reports take too much time to generate. So reports take too much time to generate. So it's gonna be, yeah. Look at them. So we have to run each individual test on each individual supported target, try to compile it, try to run it, collect all the statistics, and so on and so forth. It's kind of annoying, right? So it's like, imagine this is the iteration time between like things. Maybe what I'm gonna do, I'm gonna just create a fake reports of some sort, some fake reports. How can we do that? So this is dump reports. Okay, so we can factor out a dump reports, and reports is an array. Nah, I don't want to do that, so it's going to take some time and whatever. So here we are running the tests and stuff like that. What I can do, let's comment it out. Let's comment it out like so. Maybe the easiest thing in here, by the way, is to just append status OK. Yeah, so that's so just like make all of them pass. Right, so just make all of them pass. Okay, that's cool. Cool. Now, so what we need to do, we need to iterate all of the targets. We already have all of the name. We have all of the names. Right, so at the top in here, so this is a target name, we can factor it out. Funny enough, we don't care about the target per se. We don't care about the target per se, but we care about the target name, something like this. Okay, so I'm gonna do printf, and so I'm gonna just put it like that, as target name. So cool, here are all the names. But as already said, we have to render them from right to left. We have to render them from right to left to achieve this result, because we're first annotating the last one, right? So that means the first one should come 6502, and it should be like padded and so on and so forth. All right, so how can we reverse all of that? As far as I know, these kind of ranges, they have a special method that reverses the range. So that way, yeah, we are iterating like in reversed order. So it's kind of cool. 6502 is failing all the tests. Well, yeah, so we broke it a little bit. This is not your fault. It used to pass some of the tests. So we introduced a new style of labels, and that broke all of the tests. But people already submitted some pull requests to fix that, so don't worry about that. So that's totally fine. So that's the cool thing about getting your code into the upstream, because that way other people will also try to support it and make it compile and stuff like that, right? So it's kind of like integrates into the whole pipeline in the system. Right? Okay, so we're doing this kind of thing, and funnily enough, so now we need to pad the whole thing, and we need to pad it by the width of this thing, but we already know the width. We specifically computed it so we could pad everything correctly. We specifically computed it, so which means, as far as now, it's here, right? So this is where we computed this entire thing. So we're going to printf, and I can just do something like this. Right, so, and essentially the width, what's going to be the width of this entire stuff? Width and just empty thing. That's right. So let's freaking go. That kind of worked. Interestingly, we should probably add one for the colon, right? So because there is this colon, additional colon, and for the extra space in here. So we have to kind of add 2. So, and that kind of aligns everything more or less properly. So now, here is the interesting part. So we need to position this thing right in here. So we need to compute the width of this entire stuff. So we know the indices of each and individual target, don't we? Right, so maybe we can call it, yeah, so it's called the J. We can put this J in here. So as far as I know, it's a ZU, it's its size. Okay, so this is 4, and the amount of K's in here is 4. So which means we can literally use this value. So, and the width of the K is actually 2. So you have K and you have additional space that you have to skip. Right, so which means I can, yeah, so I want to separate this into a separate thing, something like that. So it's going to be another one, and it says 2J and nothing. All right, so let's actually see it. There we go. Look at that. There we go. That's already basically, it's almost done. It is almost done. Right. So, and now I can also add plus in here, right? So if I just add plus in here, that kind of fits this entire thing. So another thing in here is that for each K, we have to put a colon, space, colon, space, colon, space, colon, space. And what was the, how exactly did it look? Ah, this one is interesting. Okay, so we probably want to have an additional dash in here, right? So this is an additional dash. An additional dash, so that makes sense. And now, instead of doing this kind of padding, I feel like we have to do another internal iteration. So in 0J, and what we're going to be putting in here is colon space. Just colon space, nothing special. Absolute shooting. That is right. So next time you see some fancy ASCII art graphics in the compiler diagnostic or something like that, this is how it's done. It's just like you observe some interesting properties of some indices and stuff like that, and you just abuse those properties and you get pretty cool stuff in here. So yeah, that's how it's done. So that's pretty cool. All right, so let's actually run the real thing, the real deal. Right, so, and see what exactly is failing there. Position absolute coding. Yeah, like it's actually more enjoyable than doing CSS, honestly, because you have full control. All right, so it's a guess ARch64 Linux test upper. Look how easy it is. Look how freaking easy it is to just locate, right? So it's failing somewhere. Okay, so this is that. Oh. So you know what would be cool? If this entire system allowed me, okay, how can I run these specific tests on this specific target? Right, so essentially I have some flags where I do btest, target, I specify the target, and then maybe also test, right? So I don't know how to call it. It's called C for test case, right? So, and then it will run that specific test case and give you the report for that specific test case, right? So you can just observe yourself what exactly is breaking in here, because there is a lot of output in here. You sometimes don't even fucking know what is going on in there, right? So like, what the fuck is going on there? I don't know. So it's kind of funny that FASM x86 for Linux, right? It works on, you know, x86-64, but it doesn't even compile on the rest of the targets, which is understandable, right? So some of the tests are only applicable for certain targets and stuff like that. I have a feeling that maybe we should have a similar thing at the top, if that makes any sense. Kind of a similar thing at the top. Or, so the problem here is that it's too down there. Like it's too down there. We might be splitting the tests like every 10 tests and printing this thing. That's another thing we can do. Like every time we generate a report, we print 10, generate this thing. Print another 10, generate the thing. So as you scroll, you can kind of like get the sense of like what are this thing. Right. But we can do the same thing with reverse at the top. Yeah, sure. That's another thing we can do. So why not? It's kind of a similar situation. Here is an interesting thing. What if I do not reverse this stuff? How is it going to work? Oh, fuck. Okay, so let's do it like that. And here we're gonna have a status, okay, okay. This is literally, wait a freaking second. If I just do not reverse, absolute choding. Holy fuck, this is so it's kind of funny how symmetrical this idea is. What the fuck? Why is this so symmetrical? It's just like, yeah, and then at the top, you can kind of do that. So, I don't know. But with the reverse, print both top and bottom. Yeah. So that's what I want to do. So this is the reverse one. Yeah. Can you? Yeah. This is how it looks like. So yeah, actually we can try to do this kind of thing. So just a second. Let me grab your cheese. Okay. What if we try to do this kind of stuff? Though we need kind of a different thing. The one without extra arm. So it's like a, you know, I don't know how to explain it. Oh, it didn't copy, it didn't fully copy it because it didn't properly copy shit. Fuck. Alright, so this is the thing. I can put it in here. Yeah, so we need this kind of thing. Thank you. So, but it's actually, it has to be in the middle though. I feel like it has to be in the middle, so it may not work. Chat, it may not work. But anyway, but we'll see. So let's give it a try. Yeah, it's not even, well, I mean, we can always do something like that. So yeah, one Strum, I think you got it, meine Freunde. I think you got it. So let me see. So this one could be working. This one could be working. Oh shit. Fuck. Okay. 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 I think we're onto something. Oh fuck. Oh shit. So there's another one, but you only provided one. I need both of them for both of the sites. So absolute badgering. But anyway, so we're gonna go with that. Right. So we can fix that a little bit later. But that's pretty cool. That is pretty cool. That is pretty cool. What I want you to do, I want you to have some sort of a le filter where I could say, okay, instead of running like everything, run a specific test for a specific target, right? Something like that. That's what I want to be able to do. So let's introduce maybe some flags. Right. Anyway, so let me quickly just commit whatever we have in here. So what did we do in here? I don't quite remember. So we've done a lot of things. Run the tests. Okay. Run the tests in btest, like so. So we'll get this kind of stuff. So I've really done a lot of changes in here. That's quite a few. Holy shit. Oh, let's fucking go. Being a pretty productive today. That's pretty cool, yeah. That's pretty cool, yeah. So, should we attribute this code to Llama? Because it was generated with Llama. So we literally vibe coded this part of the application. So obviously I do not own any rights to this particular piece of code. So, because I'm a filthy prompter, I'm not real software engineer. I don't even know. I don't even know what to do with this piece of code, honestly. Like, I feel like I didn't even write it myself. It's just like I literally had to ask AI. And guys, I think AI is gonna replace us. Like, look, have you seen with like how easy it was for AI to generate this code? I think it's over. Like, it's completely over, right? So I could have not generated this code this fucking. Anyway, so let's introduce some flags. So BRS. So here's an interesting thing. Yeah, so let's just accept the le target. Let's accept le target. And it's gonna be something like this. Target name. So they are writing PS1 prompts that can replace TinyRiser. Yep. So that is true. It's gonna replace all the risers. Any risers in the chart? So we also may want to have like some sort of a name in here. Case name, and let's do something like flag. Pass list, by the way, to get the list of available targets. So yeah, that's a cool idea. So we can also have something like C, right? And we're not going to have default target name, because if you didn't provide any default target name, we just test for all the targets, for all of the possible targets, which we can, run. So, and here is an interesting thing. Yuri submitted a very fun code some time ago. It's just like, if you're running ARM on a platform that is neither ARM nor Linux, so it will work. Don't worry about it. So you can run ARM programs that you compiled with B from any platform. It's totally fine. Don't worry about it. I like it so much. Anyways, that's so cool. And a kind of similar situation for Windows, right? Is if you're not on Windows, you can just like run it in Y. If you're on Windows, it will just try to run it as usual. It's kind of fun. So which enables us to just test all of these things on Linux machine, right? So that's why I can on Linux machine just run. Damn, you contributed so much cool shit. I really appreciate them. I really appreciate them. Anyway. So let's fucking go. So here is going to be ptr null, right? So this is that, but that also means that we have to use core ptr. Let's fucking go. So core ptr. This one is also null ptr, and essentially you would also provide list to get the list of all of the cases, which also means that you can't have a case that is called list. Which is funny, but I mean, I wonder if it will ever bite us. So, test case. So I'm gonna copy paste le prompt like so. I'm gonna copy paste le prompt to get the list of available test cases like so. Okay. So how we're gonna start approaching this entire stuff? I'm not quite sure. So maybe I'm going to start with the following thing. So if target name is not null, I don't remember, is there like is non-null or something like that? Is non, yeah, so there is a null. Is there an opposite to null? I don't remember, because I know that there is empty and non-empty. But I feel like there is just no. Okay, I should probably not worry about this kind of stuff. You need Clippy for this kind of thing. So maybe allow comma separated target cases. I have a cooler idea actually. I have a cooler idea. Flags support lists. You know how in the B compiler you can actually do linker flags like LM, LC, and so on and so forth. This is a capability of the flags library that we're using. It supports lists. So the only thing you have to do in here is just like flag list. And now you can have this kind of stuff. And you can do the same shit for the targets. Who said not? Like, yeah. That's a cool idea, honestly. Like a target list and target name and... Damn. I kind of like this idea. But that also means that you should iterate not the test names. So essentially, this has to be, like not the target name. This has to be like a list of current targets that were... This is freaking cool. Wait a freaking second. I don't remember how to use list. I think they don't have a default value. Right, so where are linker flags? So you do flag list and you just do that. But I mean, you still need to get away, like get the list of the targets and the test cases. So that's still a thing. But anyways, so so it's called targets, and this is cases. Compilation targets to test on. Compilation targets to test on. So let's start with just targets. Let's start with just targets. Targets. And I want to have some sort of a list of the target names that we are currently, working with. So, and it has to be different from this one. So let's call it target flags. So this is target flags. This is going to be targets, and it's going to be array of targets. Right, so this is an array of targets and it's zeroed. So if target flags and list returns you flag list, which is a dynamic array. Right, so you can iterate it as a dynamic array, so it's totally fine. So the first thing we do, is it empty? Is it empty? If it is empty, we're gonna append all of the known targets into this list. That's what we're gonna be doing. Right, so let me copy paste the whole thing in here. So we're just appending all of that stuff. Gonna copy paste that, put in here. So targets di append mutable target. So we're just appending all of that stuff. Otherwise, let's say this is not implemented yet. Right. So and in here we're going to be iterating not the target names, not all of the targets, but the targets that we actually appended in here. So this is going to be targets count, and here is the targets items add J, and this is a pointer, so I just dereference this entire thing. Okay, let me try to maybe run this entire thing and go to the compilation is. So what do we have here? Flag list. So we need to have pod mod flag, and do we have to... It still has a prefix. So I should probably remove the prefixes and use the module as the namespacing, but that's besides the point. So maybe I'm gonna do that at some point. What else do we have in here? So flag list take 2 arguments, so we don't have to provide this stuff in here. All right, so unused import, whatever, that's totally understandable. So target name, what? Excuse me. This expression has type target, expected type target, found target name. Okay, so this is a different type now. I see. Okay, so that seems to be working. So now here's the fun part. So I can do T and I can say, okay, test only on UXN. Fuck, it didn't work. So, so also I need to get rid of the other test names in here. So target names, I mean. Target name, yeah, so, all right. So there's a lot of this kind of stuff. So this has to be targets. This is the count. And we need to have names, so, but we still have to have targets. So targets, items, add J, and we dereference this entire thing. But now we have the target name. Name of target, and also unwrap. Right, so that's what we have to do in here. That's what we have to do, and target names, similar situation, targets. Count, just a regular target, just a regular target, targets, items, add like this, name of target, and also unwrap the whole thing, Okay, so I should probably rebuild this stuff. Target names. It's not used anywhere anymore, but it's did I miss something? I swear to God, like this should be, yeah, so iterating, yeah, so since I supplied T, it should hit this to do, but it didn't. I know what, I forgot to parse the flags that I said I'm gonna parse, okay? I forgot. So you have to call flag parse and everything, right? So that's what you have to do. All right, so after we created all of the flags, we do flag parse, we can print the error, and also have to specify the usage, so I can use the usage from here. So that's our usage. And this is basically options, so we don't need extra stuff, only that stuff. Fuck, why don't you freaking, it doesn't parse. What the fuck, bro? I don't get it. Like, I specified the flags, I did the parsing, okay, so it should have parsed all of these things, but it didn't. But how did it work then? Why did it compile? Wait. How did it compile then? I don't rebuild it. Fuck. I don't rebuild it. I forgot to, yeah, now it fucking works. Yeah. I was building compiler, but I was not building the test system. Jesus. Brovsky. So unused variable, who cares? Give me the error. What's the fucking anal compile? Okay, finally. So, all right. So this is the to do. I'm fine. Everyone relax. So for J in 0 target flags count. Right, so, and now what I have to do, I have to do the following thing. Items add J and a dereference, and it's going to be just a name. What we can do, by the way, we can name of target, right, name of target, like this, and it may fail or not. If let some target, Emacs, freaking Emacs. Okay, so it's going to be that, and I'm just going to be appending that to the target list. All right, otherwise we also have to throw an error. We could say something like fprintf std error, or something like that, std error, unknown target, something like s, and so we're gonna put in here is this is the target name. All right, so this is the target name, and we're gonna return none. All right, so that seems to be working. So what else do we have in here? It's a pointer, that's understandable. What else do you want from me? It wants from me this kind of stuff, and do I want to dereference? I think I do want to dereference this entire thing. Target name, expected target, target of name, target by name. All right, so cool. Absolute fucking trading. So so we can enable the testing now, right? We can enable the testing. So I'm gonna just do something like this. And now I can say, okay, so also test on FASM, x86 64 Linux. Okay, and it gives you a report on all of them. It even puts them in the same order as you put them in the flags. It's kind of like, yeah, so it's kind of cool that it's also gives you the same order. Isn't that cool? That's so fucking cool. So we can now control this kind of stuff, and I can just say, okay, now test all of them. Damn, this is a very powerful system. Holy shit. I can have slices. Now I can test slices of the matrix. You do guys realize what the fuck this means? It's a slices of the matrix. This is insanely powerful. This is an insanely powerful system. What the fuck? And it's relatively easy to now add cases, right? So let's have something like let cases flags, flag list c test cases, right? So test cases. So we test this kind of thing, and now so this is the targets, and on top of that we can have let cases, and it's going to be just an array of names, right? So this is the names. So we can do even parallel testing and stuff like that. That's for sure. We can do parallel testing, but not right now. 0 yet. So this is the cases, and now if cases flags count is equal to 0, we just add all of the test names in here, right? We just add all of the test names in here. So it's going to be something like that. This is len. So was it to maintain the, yeah, so let's do I. If it's empty, we just I append mute. This one has to be mute. So cases test names. It's like that. Okay, so otherwise, what we have to do, we have to iterate through the cases flags. For I in 0, cases flags. So from my experience, you should also add the run tests that contain X flag to run similar tests. That's a good idea. We're going to implement it at some point. And stuff like just list also like wildcards. I think I even had my own library for globes in C. Just a second. Globe. Yeah. Holy fuck. Simple header implementation of globe matching. Yep. I have it. So I can use it in here, so I don't even have to, like, it's literally single header thing. 2 years ago. Look at that. Implemented 2 years ago. Kind of vaguely remember it, but yeah. So trailing, damn. So it also supports UTF and shit. Yesterday doesn't. Yeah. So I have a lot of third-party dependencies for myself. Anyways. So di append mute cases, and this is just gonna be I don't know. Case name. So there's a case name, let case name, cases flags, items, add I, and just to reference this entire thing. All right. So now, instead of test names, like every time we encounter test names, I have to use cases. Test names. So in how many places we do that? Actually, look at that. So this is literally the only place, which means that cases, so this is a cases count, so cases count, and cases items add I, so test name. So that's basically it. All right. So now what I want to do, so I build the entire thing, and I want to do test gas a arch64 Linux and a case upper. Yeah, so okay, so char is not implemented for GAS x86-64. So that's now I know why it is failing. So look how it just like localized like this. I can now say, okay, for all of the platforms. So it tests for Windows, and now I have a breakdown. This is awesome. What the fuck? Especially when you have like one test in here, right? So we can have like maybe several tests, right? So what about E? So upper and E. So now we know, so 6502, like nothing really builds on 6502. We can figure out why. I can just put 6502 in here just to see, yeah, because label style IR is not implemented. So it is 6502 failing because it needs label. This is awesome. This is already fucking useful. What the fuck? Right, so I can just narrow down specific cases and just like work on them. Biblically accurate test report. Yeah. So maybe add UXN now. Yeah, so that's pretty cool. Everything works. And now at some point we can say, okay, so we'll test everything. And this is something that we can actually run on CI. Believe it or not, we can just have one job that just runs everything on CI. We can use a tick. Why not? So let's give it a try. Let's give it a try. So where's the B test? So how is it gonna look like? Is it gonna look? It's a little bit too wide, honestly. It's a little bit too wide. I feel it's not going to work that well. So build B test. Okay, so what if for the for all of the platforms, for all of the targets? All right. It's too wide, I'm sorry. It's too wide. So we're gonna go with K. So it's just gonna be one letter here. It's gonna be one letter. So, all right. What do we have in here? So implement test slicing. I really like the name. So you use slicing. All right, so by the way, we may want to at some point introduce maybe third axis, because you have a target, but it also depends like where you're compiling, your host platform. Right, so because of that, maybe another thing we're gonna have in here is just like a host or whatever. But we'll see. So in this idea, actually, again, like it scales to more dimensions. Who said that we can't have more different axes in here, like that test different properties and stuff like that? You can call it Cartesian division. Maybe to not test slicing. Right. So here is an interesting thing. So here is, yeah. So we're gonna program in YAML a little bit. So are you guys ready? DevOps YAML programming. Let's fucking go. Anyways. So the idea here is just have one job. Can we have one job? So for one job, like for different jobs, we actually install lots of different dependencies. Let's create some sort of a mega job, or maybe it's going to be B-test. B-test is just like, you know, run all of that stuff on B-test. So installing dependencies. So we're installing clang make. So on top of that, we also want to install additional things like minGW and wine64. All of that is super important. So GCC. So yeah, so we definitely need GCC arch Linux GNU, right? So this kind of stuff. QEMA user and QEMA user here as well. So here are all of the dependencies. Right. So, and we also want to install UXN. Yeah, we also want to install UXN. Let's quickly do that. So, and we're just like cloning this entire thing and just creating the whole thing. So is there like an easier way to add additional environment variables in here. I'm not quite sure. So after installing the dependencies, like we install the toolchain, minimal and stuff like that. Yeah, I was just thinking that maybe for ARM, we also have to install. For ARM, we also have to install ARM Rust, but I think it's not the case. I don't think it's the case. All right, so how are we going to be going about that? So I'm going to do make. I'm going to do make btest. It's literally like this. And let's actually remove the rest of the jobs in here. Let's remove the rest of the jobs and see how it goes. MOS, yeah, 6502, don't think it requires anything special, right? So it's going to be btest. Oh, I was actually doing that on the wrong job. Fuck. All right, so I'm just getting tired. Don't mind me. I'm just getting tired. Yeah, so we're gonna have several attempts. That's for sure. So build examples. Yeah, so this one is relevant. Add jobs that test on different host platforms, Windows, ARch64, etc. So I think that's what's relevant in here. Okay, so in terms of the rest of the stuff, so I feel like we must finally get rid of all of this crap for testing and everything. So now we definitely don't need this thing. So this is not needed. 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 This is literally the reason why like I started btest idea, because there's too much crap in makefile which makes it super complicated and doesn't add any value. It's actually kind of insane. Right, we also have to add all of this stuff. So I don't think, do we even have fake 6502? I think I removed it at some point. Yeah, so I made fake 6502 part of this thing, so it's not even needed anymore. So let's remove fake 6502. So in terms of makefile, okay, fake 6502, code gen. So let's call it BRSS. This is all of the stuff that is needed for B. So targets like that. Sometimes it's kind of difficult to tell like what's needed in there, what's not needed in there. But okay, let's call it all RSS, and let's just rebuild everything every time somebody something changes, just in case, right? So because who knows. And now I want to also add the runner things. So let's do ls cat. Was it cat? Yeah, so it was cat. So that's the additional things that we added in here when we were factoring out the runners. So this is src runner like this, and I'm gonna put this stuff in here. For each of these things, it's gonna be like that. Okay. So RSS, Linux objects, min.gw, btest, yeah, so this is cool. We need all files, bxe, all of that is important. This one is important. Tests, they should go away. All of that goes away. Straight up. Straight up. No, that is needed anymore. So we're only building the bcompile itself, right? Btest. Also, we can build the bcompiler for Windows. That all of that is very useful stuff. Okay, so can I do B? All right, so that seems to be working. So what about btest? Can I run btest? Okay, so let's run all of the tests now. Some of them are failing. That's totally fine. Okay, that seems to be working. That seems to be working. All right. So, run btest on CI, and let's push that right into the repo. So let's create a pull request. So because I want to see the result of the CI. Let's fucking go. Implement btest. So there should be only one job. So, all right, I removed more code than I added. What the fuck? I expected that I would actually write more code. This is actually proof that this is the right thing to do. Like, I implemented the whole new freaking system, and that reduced the amount of code. So that means I'm doing the right thing then. I'm pretty sure I'm doing the right thing now. So installing the dependencies. Okay, so installing dependencies is not that interesting. I should probably add extra like queue things, right? So it doesn't shed too much of this stuff. Or maybe I forgot somewhere to add queue. Yeah, I think I forgot to add it to update, like queue for update to make it extra silent. But how can make it follow? Can you just follow? Installing dependencies, right? Installed all of the dependencies now. So cloning UXN. Okay, so it's installing UXN. That's respectable. Okay, OK1, OK2, OK3. Running tests. Okay, so we're okay. Hell yeah! So it's complaining about all of the things failed to build. Interesting. So first of all, so unused variable I and stuff like that. So this is kind of weird that it complains about that. 72. Is that what it is? Well, I mean, it's not that big of a deal. I wonder why it doesn't complain for me, but so let me see. Is that because I CD'd into here? Didn't compile, but btest did. Ah, that's a good point, actually. That's a good point. So we need to actually make btest depend on b. Yeah. All right. So now we have to compile both, and then we run btest. All right. Make btest depend on b, and let's push that right into the repo. So here comes the thing that Spiritman is talking about, right? So we are now just making modifications and looking at CI. Classic, isn't it? Freaking classic. Everybody loves it. Everybody loves it. So it's like it's a developing in a programming language, compiler for which is extremely fucking slow and located on a separate machine. Yeah, peak software engineering. This is the real software engineering. People tell me all the time that Zozin, you don't do real software development on the stream. What the fuck is this then? What the fuck is this then? I'm fighting with CI build. I'm programming in YAML. I'm programming in fucking YAML. This is like how more real software engineering can it get? It can't get more than that. Tech 256, hello. This looks early close to my day job. Exactly, that's what day job is, right? So just programming in YAML. So yeah, I'm doing real software engineering. Yay. So we're building the Scheiße. Fuck, it's broken yet again. I think it's broken. Fuck. I didn't fix shit. My hypothesis is could not open file. It couldn't find any of them. That is bizarre. Wait a freaking second. Another thing in here. Yeah. So when I'm running the test, run test. Yeah, I also expect to have this folder. But funnily enough, I think I can create it myself from btest. CDXN, but never CD back. Well, it was done in a separate step. I was thinking that maybe if it's in a separate step, it's totally fine. Right. So it's kind of difficult to tell. It's kind of difficult to tell. Yeah, but let's actually. Well, I mean, there's some valid things that we need to fix anyway. So let me do the following thing. So I'm not sure how GitHub CI works. We use GitLab at job. Okay. So I need knob or s make dir. Where is the make dir? I don't have a make dir. Oh, I think yeah. So I edit make dir in a separate session. Okay, but then I removed all that stuff. So make dir if not exists. Let's go here. Let's put it in here. So this is a link name, like so. Okay, pub fn boolean path. So this is char c char. We got this thing. Let's fucking go. Btest rs, and before doing any of that stuff, we'll probably want to parse the flags, prepare all of these things, prepare the test cases, running the test cases. So let's first create this thing. So build tests. That's what it is. Is it? Yeah, that's what it is. And return none. All right, so okay. Make btest create build tests folder for its garbage, because it generates garbage during the testing, so it needs the folder for that. It needs the folder for that. It's the funny part is that it's actually well, I mean, it's fine. It's fine. It's fine. So this test system is designed so not all of the tests may pass, right? So it's kind of like a, you know, very flexible in that regard. It is very flexible in that regard. We're giving the developers a little bit of a leeway, not forcing them to make all the tests pass. Vibe testing, exactly, vibe testing. So because we believe that the software developers should use their own brain, right, to assess how critical or not critical this entire thing is. So we're using testing as sort of like an indication for the engineers to understand what's the current status of the compiler and everything. Having some sort of like HTML page with this kind of stuff would be so fucking cool. Is there any way to make it follow, right? So it's just like show times full screen. So I don't see any button to make it follow, even though like installing dependencies is not that interesting. I think the most interesting thing is running the tests. Let's just let it install dependencies. It takes 1 minute to install it. Full screen poggers. Yeah. Like, what do you need full screen, by the way? Very useful. Thank you so much. Okay, what do we got? It's trying to run wine, by the way. That's already closer to what we need in here. Yeah, so that's working. So I guessed it correctly. It actually working the way I expected it to work. All right, this is cool. So it couldn't run on Windows. It ran on Linux. Gas kind of worked on some of these. So it failed to build these things, which is expected. It failed upper, which is also kind of expected. UXN completely fucking failed, which is, by the way, also expected, right? So because we didn't supply the correct path or anything. So something with wine. Man, this overview is insanely useful. Right, just by looking at this overview, I kind of already got the idea what's the problem, right? So Windows is probably something, I didn't have to parse through all of these logs or anything like that. Just show me the overview. Very fucking useful. I'm so glad I spent time like making it pretty and shit. Good UX, exactly. It's a freaking good UX. Damn, brovskis. Okay, so we can fix UXN super easy, like right now. What was the... So run btest on CI, so UXN, so real path, yeah, so basically I forgot to add this, so that's basically what happened. Make btest, All right. So add UXN to path. So that's one thing. Regarding Windows, I'm not sure what the fuck is Windows, because did you see the wine? Where is the freaking... This is horrible. Wine was whining about something. All right. Application tried to create window but could not be loaded. Wine32 is not installed. That was the problem, right? So let's take a look. So okay, I installed Wine64, but I didn't install Wine32. And the question is, was I installing Wine32? I didn't think I was. Like, I didn't see wine. So test min.gw. Ooh, this one is interesting, actually. There's also something about missing. So when I was doing, we were running test min.gw. All right, so test min.gw. And I forgot what it was. Test min.gw 32. So each individual test, we would set it to target, yeah. So we would compile actually Linux one, we would compile a Linux one, and then we do FASM x86-64. So that's sus. So that worked before, but then it stopped working for whatever freaking reason. All right, so failed to open args11. So this is what it says every time it does. Yeah, so, and I also need to install Wine32, but it was not complaining for me about that. Let's do again, FASM. Forgot the extension, but does it matter? Like, it works for me in here. FASM x86-64 Windows. All right, so why does it work for me? It also wants 32 bits. It also wants 32 bits. But I don't know. Right, so there you go. So on my Linux it works. Like, why it doesn't work on Ubuntu or whatever the fuck they're using? That's a good question. So it totally works. Anyway, let's actually push UXN. Let's actually push UXN. Thank you so much, Microplastic Particle 546894 for the subs. Thank you so much. That's a lot of microplastic. But yeah. But I mean, we already kind of achieved everything we need to achieve. Everything else is just like already details anyway. So we can quite easily fix Windows maybe off screen. Right. So I just want to make UXN work. I think it's pretty easy to make it work. You just add it to the path. And for Windows, Windows is always very fucky platform. So I don't think I'm going to be wasting time on it. Well, I already streamed for 2.5 hours though. So I definitely should wrap up. So it's usual Windows stuff. The usual Windows stuff. So let's wait for the UXN and we'll see. Windows when you add hosts. Well, maybe, but I mean, again, so on CI right now doesn't work something that on my machine, on Void works. So it's not really about the targets per se. Something with their wine. Wine worked before, now it doesn't. Yeah, so it doesn't work, and I don't quite understand what exactly. Don't quite understand exactly, but as you can see, UXN now works, right? So UXN target now passes because it has a path. So this one is expected. Something with Windows, I'll figure it out myself later because Windows is a very annoying platform, as usual. So yeah, that was a fun stream. I didn't expect it, right? So I didn't expect that. I'll succeed. Maybe I was just in a good mood, but yeah, so that's pretty cool. I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate it. Have a good one, and I see you all on the next recreation programming session with Mr. Azuzi. I love you. Mwah.